Hello students, welcome. Previously, lesson 23, form 4 to week 4, we were dealing with the fifth aim of calculating Faraday's first law of electrolysis, which was determining the charge on a metal or the number of Faradays, which we can write in a small letter. So today, lesson 24, we are going to proceed to the sixth aim of Faraday's first law of electrolysis, which is determining the amount of current used, which we can write I. So the formula that we are going to use here is, when we're talking about current, we can use the formula Q divided by T, where I is current in amperes, Q is the quantity of electricity passed, and T is time, which must be in seconds. That's the first formula. The second formula that we can use is that if you want to calculate current, that's I, it will be equal to M times N times F divided by Rm multiplied by T, where Q is the quantity of electricity passed, M mass in grams deposited, N the number of electrons gained or lost, that means the number of Faradays or the value of the charge of the metal, F Faraday, which is equal to 96,500 coulombs, and Rm is the relative atomic mass of element. Or you can use the formula that we were using to calculate quantity of electricity, which was equal to M multiplied by N times F divided by Rm. Then when we get Q, that's quantity, you take I, which is equal to Q that you have obtained now, divided by time. So that's the formula that you can use. So we are going to go to examples. Example number 1. We are told 96,500 coulombs of charge were produced after 10 minutes in an electrolytic cell. We are asked to calculate the amount of current used. So we can use the formula current, that's I, which is equal to Q divided by time. So I would be equal to, the quantity is 96,500 coulombs divided by time. The time is 10 minutes, but remember, time must be in seconds. We have to multiply by 60 to convert it into seconds. What we are going to get there is 160.8333 amperes as our current. Example number 2. We are told to calculate the current passed if a mass of 0.234 gram of copper is deposited in 4 minutes during electrolysis of a solution of copper 2 sulfate. And in bracket, we are given the relative atomic mass of copper to be 63.5, and we are told 1 Faraday is equal to 96,500 coulombs. So we can look at the formula, or we can use the formula I, that's current, which will be equal to M times N times F divided by Rm times T. So M is mass in grams deposited, so that's 0.234 multiplied by N. N is the number of Faradays. So here we're having copper 2 sulfate solution. It contains copper 2 ion. So copper 2 ions, they're having a charge of 2 plus or plus 2. Then that means the number of Faraday will be the value on the charge. That is 2 multiplied by F. F is Faraday, and Faraday is given 96,500 coulombs divided by Rm. The Rm given here is 63.5, the Rm of copper. Then time there is 4 minutes, but remember, we have to convert it to seconds by multiplying 60. So when we put all this in the calculator, we are going to get 2.9634 amperes. That's our current. Example number 3. We are told during purification of copper by electrolysis, 1.48 gram of copper was deposited when a current was passed through aqueous copper 2 sulfate for 2.5 hours. We are told to calculate the amount of current that was passed. So we are given in bracket the Rm of copper to be 63.5, and until 1 Faraday is equal to 96,500 coulombs. So I, which is current, is equal to M times N times F divided by Rm times time. So M is the mass deposited, that's 1.48 gram, multiplied by N. N is the number of Faradays, that, or we can just get the value on the charge of the metal. So copper 2 sulfate contains copper 2 ions, so that means the value on the charge is 2. So we are going to put there 2 multiplied by F. That's Faraday, which is given 96,500 coulombs divided by RAM. The RAM of copper given here is 63.5 multiplied by time. The time given is 2.5 hours. So that's 2.5 multiplied by 60 to convert it to minutes, then multiply by another 60 to convert to seconds. So when we put all this in the calculator, what we are going to get is 0.4998 amperes as our current. Then lastly, we are going to go to the extended questions. We have only one extended question. Kindly try it, and thank you for watching.